Hello, we are discussing about GATE 1992 ECE paper, and we are discussing about the one mark question related to electronics. Look at the diagram. It is a simple Zener voltage regulator. The 6-volt Zener diode shown in figure has zero Zener resistance and a knee current of 5 milliamperes. The minimum value of R, so that the voltage across it doesn't fall below 6 volts, is A 1.2 kilo ohms, B 80 ohms, C 50 ohms, D 0 ohms. Okay, so what was given is nothing but Vz is equal to, the given values is Vz is 6 volts. Next, knee current of Zener diode is also treated as Iz minimum. Iz minimum is nothing but 5 milliamperes. Knee current is also called as starting current, that is nothing but the minimum current required for the Zener diode to keep it in the Zener breakdown region where it acts as constant voltage, where it maintains constant voltage. So that knee current is given as 5 milliamperes, that we are taking it as Iz minimum. Okay, and Zener diode maintains a constant voltage during a range of currents starting from Iz minimum and ending at Iz maximum. If the current flowing through the Zener diode is above that Iz maximum, at that time Zener diode also gets breakdown. That is nothing but it will become useless. So now we are going to calculate the minimum value of RL. That is nothing but this R is, we are going with minimum R, but the voltage across this one is nothing but 6 volts Zener diode, where it is maintaining as a constant voltage 6 volts. Whenever R minimum, at that time current flowing through R will be maximum. So this is IL maximum. So whenever this is, if you are going for this one, this point is at 10 volts and this is at 6 volts. We know the resistance value, so that we can calculate the current flowing through it. So say it as Is. Is can be calculated as Is is equal to 10 minus 6 divided by 50 ohms, which is nothing but 4 by 50, that is 80 kilo, that is 80 milliamperes. So 80 milliamperes Is. So Is is nothing but sum of the currents which are flowing through these two branches. So the two branches are going to be, normally we can write it as Iz plus IL, but as load is going to be changes, Zener current also can be a range from Iz minimum to Iz maximum. Otherwise IL can be a range in between IL minimum and IL maximum based on the load, so that we can write different equations like this. If out of Is, which is constant, remember that one, Is is going to be a constant one because input source is going to be constant at 10 volts. So that out of that constant current, if Iz is taking maximum current, at that time the load should take minimum current, so that will be treated as IL minimum. Otherwise some other case is nothing but, if IL is taking maximum like this, minimum R you are going to be connecting. R minimum is nothing but the load current is maximum. By that time Zener diode should take minimum Zener current such that it will be in breakdown region, then only it can act as voltage regulator. By that time we can write this equation, Iz minimum plus IL maximum. So we are going to use this equation of Is. Is is equal to Iz minimum plus IL maximum. So from this one, Is is equal to 80, Iz is 5, and IL maximum we can calculate. So IL maximum from this one we can calculate it as 75 milliamperes. So IL maximum, if you know, at that time RL minimum can be easily calculated. RL minimum is nothing but Vz divided by IL maximum. Vz is nothing but 6 volts divided by 75 milliamperes. So the value of this one is 80 ohms. So the answer for this one is nothing but B. So the minimum R required so that the voltage cannot below 6 volts, that will be the value as 80 ohms. So Answer is 80B. Thank you.